Hi, my name is Caity Rigg, and I'm an environmental studies student at the University of Washington. My capstone project is titled Using Underwater Video Analysis to Understand Fish Responses to Bottom Trawls and Reduce Bycatch of Threatened Green Sturgeon. I worked on an internship with NOAA Fisheries. My site supervisor is Susan Wang, and my faculty advisor is Andre Pent. There's a threatened population of green sturgeon in California's rivers and coastal waters that is being studied for conservation by NOAA Fisheries and California Department of Fish and Wildlife. The California halibut bottom trawl fishery has encountered some of these sturgeon as bycatch in commercial fishing. Bycatch is the unintended catch of species when a bottom trawl net is dragged along the seafloor. Under the Endangered Species Act, the sturgeon must be released back to the ocean. However, a study with satellite tags conducted by the same team that I worked with shows that the post-release mortality rate is 18% due to stress and injury during handling. So the best case scenario is to avoid bycatch in the first place with mitigation techniques. I focused on two research questions to address this. One is there significance in how green sturgeon respond to a light touch bottom trawl relative to a traditional bottom trawl? And second, can the use of illumination be added to bottom trawls to act as a bycatch mitigation technique? Figure 1 shows a diagram of a traditional bottom trawl. A light touch has a wider wing length, a wider net, and no rollers or bobbins on the seafloor to reduce impact and the ecosystem there. For my methods, I analyzed footage from cameras seen here in figure 2 that were placed in the nets of bottom trawls and recorded each species and its response to the net so that we may better understand target and non-target species interactions with it. The vessel I analyzed data for used a light touch bottom trawl. I conducted a literature review to address the illumination technique question. During my video analysis, I witnessed 4 green sturgeon enter the net that we've confirmed were able to escape, as there was no observer data from the vessel that they were accounted for on deck. In figure 3, I show that there are 2 that were slow or not actively swimming. One was steadily swimming away from the net, and one exhibited a darting behavior that was categorized as a successful escape attempt in the light touch gear. In the traditional bottom trawl, one steadily swam away from the net, and one showed slow or no movement. The only sturgeon seen on deck and observer data came from a traditional bottom trawl. It's also important to consider that the trawl types do not impact the target catch. Over 70% of halibut and other target flatfish exhibited behavior categorized as darting into the net or moving into the net, suggesting that they're aware of it. But there's no dominant response in target catch to the light touch gear. Figure 4 shows percentages of each species abundance. So surf perch, forage fish, and roundfish are typically seen in groups and are small enough to pass through the net, so they don't contribute to the bycatch rates. But it's worth showing the relative abundance, with green sturgeon being less than 1% and flatfish being 1.2. It's worth noting that there are no sturgeon bycatch in the light touch trawl. However, there's not enough observations yet to determine if gear types show a significant difference in this data, and it should be continued to be collected. In figure 5, I've outlined the best image I have of a sturgeon swimming away from the net, and this shows how difficult it can be to identify and observe species in these water conditions. Studies from my literature review suggest that an illumination technique may be utilized, as sturgeon seem to have a repulsive effect to red wavelengths in the visible spectrum of light, strobing at a low frequency and in white ambient light. I did not find studies that have considered halibut and other target flatfish species response to this type of light, and it's important to consider that this does not detract the target catch as well. So while this is a possible solution, it will need further study. I suggested a future study that evaluates halibut response in a controlled environment, and if there's no attraction or they are at least indifferent, then a cross-design study may be used with vessels equipped with each type of trawl, and one with illumination and one without, to be able to study all species in their natural environment. The continuation of this research and implementation of bycatch mitigation techniques will ensure the survival of green sturgeon and maintain the sustainability of fisheries, allowing them to continue to operate and supply the seafood industry in the US and elsewhere, and to not jeopardize the threatened population in the process. The rebound of this population will aid in marine biodiversity, which promotes healthy ecosystems, increases ocean productivity, and helps species to adapt to the environmental changes that we face today. I hope that the continuation of this project to consider trawl types and illumination will be further pursued, and that bycatch mitigation techniques prove useful for fishery management. I'd like to thank my site supervisor with NOAA Fisheries, Susan Wang, my faculty advisor, Andre Punt, Christine and Benson from California Department of Fish and Wildlife, and my internship partner on this project, Caitlin. Thank you all for coming to my presentation.